In this video, we're going to look at multi-step stoichiometry questions. Stoichiometry being mole conversions. Before we've done molar mass conversions with just like the one step, the one conversion factor, and we've done mole ratio as a conversion factor. But this time, we are going to do two conversion factors in one problem. And so our goal is that you will be able to use molar mass and mole ratios as conversion factors in multi-step stoichiometry questions. Our equation is 4Na plus O2 makes 2Na2O. And our question is how many grams of Na are needed to react to produce 8 moles of Na2O? So normally if we were just going from moles of one substance to moles of a different substance, we could just use our mole ratio because our mole ratio helps us convert between moles of A and moles of B. That's how we go from given one molecule to given a different molecule is through our mole ratio. But our molar mass is how we get between grams and moles. And so our mole ratio is really only how we can get from one type of molecule to the other. But what it doesn't do is put it in grams. That is what our molar mass does. So we're going to have to use these together to help us change from moles of one substance to moles of the other, and then to use our molar mass to help us go from moles to grams. And so given these types of problems, there are two ways to go about it. Our first way is that if we're given grams, you want to change your moles of whatever substance you have, change it to moles. So we start with grams of one substance, but because the only way we can change from one substance to a different substance is through our mole ratio, we have to first put our grams of that substance into moles so we can change from substance A to substance B. So once we change grams to moles using our molar mass, we are going to use our mole ratio to change from moles of substance A to moles of substance B. If we're given moles, we're going to flip the order in which we use them. Because we're already in moles, we can go ahead and use the mole ratio right away to change from moles of substance A to moles of substance B. Because we're already in moles, we're not given grams to start with, so we don't have to worry about changing that into moles to change from substance A to substance B. So because we're already in moles, we can go ahead and do our mole ratio first. Our second step is once we're in moles of our new substance, we're going to go ahead and convert from moles of that substance to grams using our molar mass. And because our molar mass only allows us to go between moles of a substance to grams of that same substance, we're going to use that second. So our question that we mentioned earlier was how many grams of Na are needed to react to produce 8 moles of Na2O? And so our known number that we start with is the number that they give us. They give us 8 moles of Na2O, and then they want us to find how many grams of Na. So those are going to be our new units. That is what we want. And so we are starting with moles. We start with moles and we want to go into grams. And so looking at our two options, our two paths that we can take to solve this equation, we are given moles and we want to find grams. So we're going to go with option 2 for this. We're going to use our mole ratio first and then our molar mass. And so our first conversion is going to be mole ratio, and I will show you why we use that. And then our second conversion is our molar mass. So we know that our mole ratio we get from our balanced equation. Because we are going from Na2O to grams of Na, that's what our mole ratio is going to be between. It's going to be a certain number of moles of Na2O to a certain number of moles of Na. From our previous video, our mole ratio conversion video, we know that we get those numbers from our balanced equation. So we are just going to use our coefficients as those numbers. So for moles of Na2O, because we have a 2 up front as our coefficient, we're going to have 2 moles of Na2O. Our number of moles of Na is going to be, oops, wrong color, is going to be 4 because we have a coefficient of 4 in front of Na. And so now that we know our mole ratio, the other conversion factor that we're going to need is our molar mass. And the way we decide which molar mass we're going to need is we need to look at what are we putting grams in, because they want us to put our answer in grams rather than start with grams. And so our molar mass, once we turn our starting moles into our new number of moles, we are just going to go ahead and change that into grams of what we're looking for. And because our grams of what we're looking for is Na, our molar mass is going to be 4 Na. And so we know from our molar mass that there it is, that our molar mass is the atomic mass times the number of atoms in 1 mole. So in 1 mole of Na, we just have one Na atom, and therefore our molar mass for Na is going to be the same as the atomic number, which is 22.99. We know our molar mass of Na is 22.99 grams per 1 mole. So now that we know our known number, we know what we want to find, we know our mole ratio between the two molecules that we need to go between, and we know our molar mass conversion factor, we can go ahead and put it all together. And so the number that goes up front is always our known number, our given, that they give us to start with in the equation, which is 8 moles of Na2O. So we're going to go ahead and write that in the front. And we're going to make sure that we not only write moles, but which molecule that it goes with, because we're going from one molecule to the other. We really want to keep track of what we have. So we can't get from one molecule to another without using our mole ratio. That's how, that is the only way we can go from converting from one molecule to a different molecule is through our mole ratio. Because our molar mass, it is only for going between grams and moles of one substance, not between different substances. The only conversion that lets you go between substances is the mole ratio. So we have to put that first. Because we're already in moles, we can immediately change it into moles of a different substance. And so that's why that conversion goes first. We know that our old units are the units that we start with, which is Na2O. So we're going to go ahead and put that on the bottom because old units always go on the bottom. Our new units are going to go on the top, and I'm going to write those in pink. We have to convert 2 moles of Na before we can convert that into grams of Na. And so our new unit for our first conversion is going to be moles of Na. So it's a temporary new unit because it's not going to be our new unit at the end. So once we know what are our old units, what are our new units, and where they go in our setup, we can go ahead and put the numbers from our mole ratio with those units. So we know for our mole ratio that for every 2 moles of Na2O, so we're going to put 2 with the moles of Na2O, there's 4 moles of Na. So we use our numbers from our mole ratio for our first conversion in our equation. Our second conversion is going to be our molar mass. So now that we have changed from one molecule to the other through our mole ratio, we're left with 4 moles of Na because these cancel out, top and bottom. So we're left with 4 moles of Na. That, our first new unit, becomes our second old unit. So we're going to go ahead and put those on the bottom. So I'll say that again. Our first new unit becomes our second old unit. So whatever unit you have on the top for your first conversion is going to go on the bottom in your second conversion. We know that our new unit, what we want is grams of Na, and because we can convert from moles of Na to grams of Na through our molar mass, we're going to go ahead and put grams of Na up at the top. Now we can go ahead and put our molar mass conversion in the numbers in that conversion in that conversion spot. And so for every 22.99 grams, so we're going to put that with the grams, we have 1 mole. And then moles of Na cancel out because we have 1 on the top, 1 on the bottom. And so what should be left is, like the only thing not crossed out should be grams of Na. So we can put this in our calculator exactly like we see it. We can do 8 in front, parenthesis, 4 over 2, parenthesis, and then up top we had 22.99 over 1 mole. And our answer is 367.84 grams. And that would be our answer. So the number of grams that are needed to make 8 moles of Na2O is 367.84 grams of Na. So the other way of doing